start new topic, gear dynamic.
Lagi tapi banyak juga tapi ya.
Okay, so take a look the questions. So a heavy load dough mixer is commissioned to be utilized at the cooking site for 5 years at 40 weeks per week per year and 6 days per week and 12 hours per day. So the mixer uses V-belt system as indicated in the figure and is driven by DC Shanwood motor having 180 on-feet torque. The system has speed ratio 3.71 and easily exposed to oil splashing condition. The small pulley has a diameter of 5 inches. Interim contact angles of 150 and rotates at 250 rpm. So kalau you lihat soalan ni, kalau you tengok soalan ni, inilah data-data, all the data that you should have. Okay, to ensure at the beginning before you start. Even your project, your major projects, so supposedly you should have this data. Okay. Even though you give assumptions, kan, you buat you assume certain data, but that assumption doesn't mean that you're just giving blindly. So you should have some justification why. Okay. And using Mitsubishi manual provided, the engineers has to compute. Okay, this is the figures. Okay, very simple. Kan, pulley kan, dua pulley. And first determine the transmitted power and the interim center distance. Sebab apa? Sebab dia bagi interim contact angle. So nombor dua, if the transmitted power is 85 horsepower and the interim center distance C is 28 inches, determine the suitable belt length, the center distance C for the mixer if the pulley is attached at the inner of slack side. You must choose the closest belt length from the Mitsubishi catalog lineup, and then the rest is for another three questions. Okay, so the data that sometimes the data kalau pada you lah, for example, if you have calculate the torque, okay, kalau you dah calculate the torque, required torque kan dalam you punya major project required torque sekian untuk motor. So sebenarnya from that required torque kan, so you dah boleh dah kira the minimum horsepower. Kan? Some you are given horsepower, okay, then you could calculate the torque. Right? So saya bagi you beberapa minit untuk you fikirkan soalan ni. So soalan ni you boleh download dalam you punya e-learning. Ada dalam e-learning. Okay, so sebagi masa you fikirkan, plan, tengok apa, uh, data book tu. So ke atas semua ada equation. Walaupun you tak boleh dalam masa singkat sekarang ni you tak boleh kira habis, at least you have to know which equation that will be used in question 1, 2, 3 and 4 and 5. Okay, so I give you some time to think. Okay, nanti saya tanyalah, saya panggil. Jarang saya panggil kan. So I give you some time to think. Right? So you boleh bincang dalam group lah, dia boleh bincang. So saya off video saya dulu, saya bagi you masa untuk cari beberapa soalan, beberapa equation, at least equation you tahu equation gunakan ni, figures ni untuk ni kan. Okay, nanti saya akan cuba tanya seorang-seorang. Alright.
Assignment 3. Assignment submission B apa? Mana soalan dia? Sorry. That's good actually. Eight hours a day. Itu yang cautious ada. Kita bebas selected HD KS. HD KS ni apa? Power design. Yang pertama sekali, requirement. FKS. QO. QO sini. So how was the day? Dah mixer eh? Transmitted power HD. Saya HD. Dia bagi HD je. Design HD. Oh, design power, power tu design ya. Driven by H. So 555 HP dah tu. Itu lash. HD kan. So siapa HD dia? Kita sebagai tahu lah. Small polygons yang kena contact. Pasal tu lash HD. Itu cari HD eh. It's driven by DC motor top. Engine. Dia kata DC tu. So KO. Harusnya ni ambil cikgu dia ialah 8 hours a day kan. 12 hours a day. Combustion engine. decision motor. So apa tu? Orang sikit. Mungkin 1.2.
Okay, the first thing, what's given? Okay, given is the motor, speed motor. This RPM. And then also given torque. Torque is 180 pound-feet. Then given DD, 5 inch. Speed ratio, 3.7. Then the wrap angles for DD interim is 150 degrees.
DD.
The first question determine the term transmitted power, HT. So dalam Mitsubishi catalog, they use the symbol HT kan. Tapi dalam buku Jovial, dia guna W dot.
Very much.
So, kita tahu kalau dalam buku Jovial, W dot equal to T W. This from Jovial books.
Semua boleh tu lah.
So, since we are using Mitsubishi catalog, so kita gunakan HT lah. T W. So what's given? Given torque. And then given is speed of the motor 2,500 RPM. Okay. Tapi in the question is rotation speeds, omega. So you just need to convert. And ini horsepower. Kan? This one horsepower. Given torque dalam pound feet. And then also given is RPM. So just need to convert radial per second. Okay. The first thing you just darabkan dulu. Just convert, need to convert, then darabkan. Okay, so let's say kita ada HT. So torque given 180 pound-feet. Kemudian 2,500 RPM. Okay, kemudian just convert this one. This time two pi radian divided by
60. Ni
60.
kau tengok Omega ni dia
Divided by?
mana sial
60.
60.
sial
60 second.
mana-mana mai ya babi. Aduh, macam mana bodoh.
Nanti unit dia you akan dapat X value, you akan times X value, you akan dapat unit pound feet per second. Okay, so you just need to convert pound feet per second to horsepower. Okay, sebab at the end you need to use horsepower to further calculation. Okay.
Tu tiga macam mana je. Omega ada.
Okay, the next questions. Okay, jawapan dia, nanti you kira Nanti you kira sendiri jawapan dia 85. 17 horsepower. So the next is center distance interim. C, you need to calculate the C, but interim. So the question given, the equation that you have to use is the given is rect angles for DD. 180 minus 27.3 divided by CI. So DD is given in inch, 5 inches. Kemudian speed ratio also given. So kita tahu speed ratio sama dengan DD divided by capital D, driver driven divided by driver. Then you akan dapat D equal to speed ratio .7 10 5. Dapat 18.5 inches. Just masukkan the value. Okay, ini this one given, and then ni ada, then you get this one. Okay.
Ni question mana?
So this is 25.8
Ni question mana?
inches. Interim.
Untuk Omega okay, speed ratio.
Okey, soalan seterusnya.
Ni ya.
If the transmitted power is 85. Okay, kita dah kira dah 85.7 and then dia beritahu lah. The next question is just 85, just take 85. And the interim distance is 28. Determine the suitable length and distance C for the mixer. Right. Untuk dapat suitable length, okay, so first you kena type of belt lah, you kena tahu type of belt apa. Untuk tahu type of belt, so given is HT equal to 85 dan C interim is 28. So then untuk dapatkan type of belts, you kena akan refer figures dalam data books tu figures 1.11. So data 11 ni you tengok saya buka. Okay, for data 11, you need to small pulley and okay, figures 11, and you need to design power and small pulley. Okay, design power and small pulley.
Macam mana 90 speed?
So for design power, so which is HD kan? Ialah HT times KS. Dan KS ialah
Apa tu?
KO plus KI plus KE. So what's KO? KO you kena tengok table. KI. Okay, this is KO. This is KO. $12 DC shunt wound motors 12 hours. Kemudian door mixer 1.2. So KO is 1.2. Then KI you tengok kat sini. Belt slag inside of belt 0. And KE oil or water splashing. Also, semua 0.2 lah. Okay. So kemudian you akan dapat, you masukkan value, you akan dapat 1.4. Kemudian you akan darabkan then HD, you akan dapat 119. Okay, then you tengokkan table from figure 1.11-1 tu you akan dapat type of belts. Dia punya di RPM 250. So kita tengok value dia. Ni kan? Small pulley speed 2,500. Small pulley speed is 2,500. $2,500 somewhere here, and then dia punya HD is 119, 12, 200, somewhere here lah. So maknanya types of B. Okay, belt type B. So bila you have been you dah decided the type of build, so all the table nanti you akan guna B types. So belt B. Dan soalan dia ialah
HD 190.
suitable bed length and center distance. Okay. So maknanya you akan kira suitable bed length interim, equation yang digunakan 2CI 17 So then you akan gunakan tables 110. Okay, find the closest bukan paling besar atau kecil, tapi the closest, paling hampir. Dalam soalan paling hampir. Okay. So di sini you akan kira, you akan dapat 92.9. The closest one LD you akan dapat 92.8. You refer table ni. Okay. Kemudian center distance C equal to B plus B squared minus 8 DD minus DD squared divided by 8. So you kena kira B dulu. What is B? B is equal to, so length being calculated, dia dapatkan length dah dapat. So LD minus pi DD plus D. Okay. So using this formula, you get B and B, so you enter this B. Okay, so then you get the C is equal to 27.1 inches. So the next questions. Determine the rotational speed of large pulley, right angles for small pulley and large pulley. So just using the formula, right angle, corrected means tadi you gunakan interim, so you dah dapat C, the actual C from the catalog. So you just use from the catalog. This is minus 57.3, just using the previous formula. Divided by C. The larger one is 180 plus 57.3 dd divided by C. So for this rotational speeds and machine, so kita ada, you know that the speed ratio equal to N motor divided by N machine. So kira N machine. Motor divided by speed ratio. Okay, then you just insert all the value. So you akan dapat 676 RPM. Speed. This one you get 151.46. This one you get 208.54 degree angles. Right. Okay, the next question, numbers of belt. Determine the numbers of V-belt needed for this system. Numbers of belt. So kalau you tengok equation, this one semua dah ada, you just refer numbers of belts. Anda kata you tak tahulah formula apa yang nak pakai kan. You just refer ujung sekali, dia ada ni, nampak ni. Okay. Numbers of belts. Okay. Numbers of belts. HD design power divided by correction power rating HP. AC. So what's AC? And so HC equal to HS plus HA times KC. Okay, semua ada kat sini. Semua nanti you akan, sebab first we need to decide type of belts. Okay, bila dah decide type of belts, ni K0. Ini pada formula dia interim. This one. Okay. Okay. HS, HA. HS, HA. Okay, numbers of belts equal to HD divided by HC. So HC you kena cari HS plus HA from table time KC. Okay. HD dah kira tadi dah. Okay. Kemudian KC equal to K theta times KL. So all from the tables. Okay, this K theta, table 616. So this KL is table 17. Okay, then K theta, you get from the table, you get 0.93, and then KL from the table, you get 1.01. Multiply, then you get KC is equal to 0.939. KS, then S dan HA. And from power rating tadi, small pulley 2,500. 2,500. And then small pulley diameter, diameter dia ialah 5 inches. 5. $2,500, 5 inches. So HS is 6.38. Kemudian HA, you can dapat speed ratio. Speed ratio dah kira tadi, kan? Speed ratio dah kira. Speed ratio dah given 3.7. Speed ratio given 3.7. 3.7 more than 1.57. So 2,500. Ini you ambil pulley dia 6.38, and then untuk HA 1.57. Okay. So HH you akan dapat 6.38 dan HA akan dapat 1.47. This is from power rating table. You kena pilih power rating table which types of belt. Kalau you salah pilih type of belt, salah. Okay. You masukkan value, all the value, then you kira. Kira number of belts, you akan dapat 15.9. So approximate, you akan pilih 16. Minimum pieces. So next question is, what is the minimum allowable rotational speed for the small pulley to operate? Minimum allowable rotational speed for small pulley to operate. So now you are using B types of. It's a B types power rating. So this is A types. This is C types. This is D types. E. Okay. Perbezaan A, B, C, D ada kat depan dah dalam buku tu. Dalam ataupun dalam e-book juga ada tulis. So ya, tengoklah. So now you are using B types So this is the small pulley speeds, RPM. So what is the minimum allowable RPM, speed for the small pulley to operate? So this is B types. Okay, B types. Maknanya any speed dalam ni lah yang dibenarkan dalam operate. Untuk operate this B types. For operating these B types, what types of what is the RPM, minimum RPM, allowable RPM? So just tengok ni lah the value. So the range is from, for the B types, allowable is 100 RPM. The maximum is 5,000 RPM. Okay. This is the range. So the minimum is 100. Okay, the minimum is 100. The maximum is 5,000. Oh, 5,000, yes. So the minimum 100 RPM. Kalau ada soalan maximum, is 5,000 RPM. Okay, that's all. You just refer all the tables. And this table ni. Kena just tahu kena guna table. Formula dia pun ada kat belakang semua. All the formula given. KD kan. Ni pun dah ada. Number of bells, AC apa dia. Required. Semua ada dekat sini. So KL pun sama. Kan, tadi ada KL. Kan KL ni, length this designation L. So value dia, types B. And K theta, you dah perlu kira D. Then dah ambil K theta berapa. So the thing is, the first thing you need to choose the right belts. Sama juga dengan you punya major project lah. You punya belting size tu, you just follow the step. Follow the step. Kalau kata perlu pengiraan forces, this all the pengiraan forces kat sini. Tension, torque berapa, semua ada kat sini. Tight side tension, slack side tension, tension ratio, span length, semua ada all formula at the back of the catalog. You just need to explore. Okay, need to explore for your media project. Once you already explored, so any question, so I think you don't have much problem. Okay, ada soalan? For belt.
Doktor, untuk cari length tadi,
Length, LD.
LD, kita akan guna CI tu guna yang kita cari ke intermediate length, intermediate center length.
Interim.
Sorry, interim center distance center, betul?
Yeah, sebab given is C interim. Okay. So once you get interim, then nanti you akan adjust dengan katalog.
Okay, doktor.
Okay. Okay, as usual, just you buat semula, then masukkan dalam as your assignment. So we continue to the new topic. Okay, this topic is design of gear to strength. Maksud dia apa? We need to predict. We need to predict the failure of the gears tools. Kan? Gear tools kita predict, and then from prediction we our design power or the torque required for that gears should be not beyond, okay, not beyond that the strength of the gear tools. So kalau kita dah identify the failure of the gear tools, so maksudnya kita punya torque ataupun power jangan beyond, don't beyond that. Otherwise, it will the gear tools will our gears will fail. Okay. So we have learned the forces acting on the gear tools. Okay. These are the gear train. And then from the gear train, then we the free body diagram for the gears, and then we identify the torque and then all the forces related at the shaft of the gears and also at the gear tooth. So this coming from our previous topic. So it has two types of primary failure modes for the gears. Okay, ada dua. Okay. The first thing, the first one is tooth breakage. Maksud dia apa? This is the gigi gears, the gear tooth. Then the brake. This brake, kan? This brake, because due to the excessive bending stress. Kan this gear tooth will match with another gear tooth. Okay. Driver and driven. Okay. Push together. Push. We have this FT kan. So it causes the bending, then it could fail here. Another one, sebab gear tooth dekat sini kan, ke bawah ni, ke atas, is surface pitting or wear. Maknanya mungkin akan ada crack dekat area sini ataupun akan ada pitting ni due to the surface pitting. Surface. Tadi due to bending, this one is due to on the surface. So this is due to excessive contact stress. So nanti kita akan tengok both these two types. One's here and the one is dekat sini, dekat surface. Okay, dekat surface. Okay, the first one is for the bending. For the bending. Bending means akan fail di sini. So an equation for estimating the bending stress in gear teeth in which the tooth form enter into formulation was presented by Wilfred Lewis. Okay, mula-mula kita akan gunakan the formula from the equation or the formula from this Lewis lah, the assumption. Okay, assumption given by this Lewis. Okay, this is the gear tooth. This is radial force, the forces lah, forces. Forces. Then the component of forces acting on the gear tooth, kita tahu we have radial force and tangential force. Okay, and then ni dia punya H dia from the neck. Okay, dari sini. And this the B, the face, okay, the width of the gear face. Okay. And the assumption dia gunakan dalam keadaan apa? Tiga segi rectangular. Okay, assumption made in deriving Lewis equation. Okay, the load is applied to the tip of the single tooth. Yeah. And then the radial component of the load FR is negligible. Then the load is distributed uniformly across the full face width. The stress concentration in the tooth fillet is negligible. Kan, tooth fillet ni, macam ni, ni fillet lah. Kalau you buat finite element, you buat kat sini, memang this is memang you akan dapat stress concentration kat sini. Nah, kalau you tengok, it is 1892. 1892. Another forces is sliding friction are negligible. Okay. So how the bending occurred in the gear tooth? Okay. How the bending occurred? Okay, this is the basic equation yang digunakan. So you boleh derive sendiri sebenarnya. You boleh derive sendiri sehingga you dapat okay. Until dia dapat these equations. This is the final equation yang Lewis gunakan. Okay, so this is the tooth. Saya derive sikit lah. Okay, this is the force. Force digunakan simbol WT, tangential force. Radial, komponen dia radial, the force macam ni sini. Okay. So dia kata tip force. So this is T, this is W. Ataupun dia guna F ke. Okay, this is the fillet. Okay, this is L. This is T. Okay, this is the point fillet. Dia akan ambil 3 segi daripada sini. 40 darjah, 90 darjah. Okay. And the face, ketebalan dia, this is F. Okay, ataupun B lah. Face dia, F. Let's say kita ambil this one F lah. Okay, dia buat soalan macam it happened for cantilever. Cantilever apa you ada? Sini you ada L. Sini you ada lebar dia width for F. And this one you ada Y maximum. And this is kan daripada tengah kan? Tengah ni. So this is Y. So from the equation sigma equal to m y divided by inertia. So you pecahkan, dapatkan y ni. So moment by 2. This is thickness T. So this is inertia 12. Width dia, width times thickness dia. Kemudian this is moment is WT times length dia, T squared divided by, dalam equation awal B lah, okay, FT. Saya guna FT divided by 12. So you simplify dia, you akan dapat 6 WT L T squared. Okay, this is sigma. Okay, kemudian dia ada rectangular in the middle. So this is the rectangular. Tengah ada T divided by 2, this is the L, this is the X. This is the L, this is the X. Okay. This is T, separuh ni T over 2. Okay, this is the similar rectangular. So you akan buat similar one, Tx equal to L. Okay, L square. Kemudian you akan dapatkan L dalam bentuk L T squared over 4x. Okay. So this L equal T squared over 4x ni you masukkan dalam this value. Dapat masukkan dalam this value, then you get sigma equal to T squared over 4x FT. Okay. Okay, until they get the equation and until they get the Lewis form factor. Okay, Lewis form factor. Kemudian dia convert until they get the formula. Okay. This is the example of derivation of the Lewis equations. We just apply. Okay, we just apply the equations. We don't, at least you know how Lewis derive, which the originals assumption and how he did, how they get the equations, okay, the form. Lastly, selepas tu dia boleh tengoklah kemudian. Okay, cuma FT ni tadi equation yang buat WT, tangential force, dan B ni equation saya buat dalam bentuk F, phase. So lastly, they get these equations. Yang ni tadilah. T squared for H ni. Okay, kemudian dia keluarkan, then they extract the Y, this Y. Y. And they call it Lewis form factor. Okay, and then they convert for use the diameter pitch. Okay, and Y. Okay, they get this one. So for the diameter pitch, so this is the Y. Okay, and for SI unit using modules, it's the Y. Where the Lewis form factor is one. And the Lewis form factor actually the tables. This is a Lewis form factor. Okay, depending on pressure angles and the numbers of these from equations. So Lewis 1892. Okay, so he got this equation and he did the experiment. And after that, the gear association revised the equation. Okay, the Standard American Gears Manufacturers Associations revised the Lewis equation and give the factor. Add more factor from the Lewis equations. What is the factor? Okay, this for diameter pitch. Okay, this for diameter pitch. Okay, we use these equations. This for P is diameter pitch. And then we have tangential force. And then phase width, lebar gigi gear. Then add tadi the Y, ni the J, tukar. Untuk Spurs gear geometry factor J. Okay, kalau you tengok tadi, this Y, equation is Y. Okay, this Y. For ACMA, they revise the equation, then they put Spurs gear geometry factor. What is Spurs gear geometry factor? This factor include the Lewis form factor. Dia dah masukkan dah. And also stress concentration factor. Dah masukkan factor ni. Okay. Based on tooth fillet, radius of 0.35 diameter pitch divided by diameter pitch. Note that the value are given for no load sharing and also load sharing. What's load sharing? Non-precision gears, and load sharing is high precision gears. In load sharing, the J factor depending on the numbers of these. Sama juga macam Lewis factor ni. In mating gears. For this control the contact ratio, which in turn determine the highest point of single tooth contact. Okay, nanti kita go for the graph. Kemudian kita ada KV, velocity dynamic factor, then KO, overload factor, dan KM, mounting factor. Okay, kalau you tengok all the engineering ni, all the engineering, so they add more factor. Macam kita safety factor, kan? So this factor will influence the original, the initial equations. Okay, we have the initial equation, but in the real life, the real environments, okay, so that machine will experience with different factor. Okay, sama juga macam same as you learn VBEL. So many factor will add on to the initial equations. Okay, so mounting factor, overload factor, velocity factor. So all the factors given in the initial equation normally, the manufacturer has done. Okay, they did already. Okay, the experiment and then give the factor. So most of the factor sometimes coming from PhD students, researchers. Okay, buat experiment and then get the factor, publish, and then macam tu lah. Okay. And all the factors come. Sometimes they will. Sometimes they find the new factors. Okay, because the research is going on. Okay, research is going on. So, for example, the researchers or PhD students, so the academician found something new. So they will propose and then add on to the more factors will. So therefore, sometimes you will see now 2022 you see this factor, and then when you go to industry, so you may find more factor, kan, sebab maybe that manufacturer found that more factor should be added in the ACMA equations. So you more factor. Okay, this is the basic. Okay, the basic factor that you have to know. KV, KO, and KM, and J as well. So this is the table refer. Okay, table ni dalam apa? Data books tu ada tables. So we tengok data books. Okay, this is the J factor, geometry factor. No sharing. Okay, no sharing means no sharing non-precision gears. Okay, pinion and gears no sharing. So ada berapa? You tengok. Okay, dalam graf ini, in this graph, no sharing load. Okay, no sharing load. The first no sharing load. Okay, dalam graf yang sama, no sharing load. Dia ada dua. The first, this is sharing. This is no sharing. So no sharing. Dalam graf ini you tengok you ada J factor. Factor J. Then numbers of teeth. Okay. And also 20-degree full depth teeth. Okay, angles. Okay. Sebab ada 25, ada 30. So the data given in juvenile books, so just refer. Okay, 20, 25. Okay. No sharing, this is the only graph. Sharing, this is the graph. Okay. So no sharing means, for example, for the pinion 20, numbers of this 20, and gears is 30. Okay, J factor, kita tengok separate 20, then bring to J factor, you get this factor. For 40, it's 40. Okay, go up until the graph, then go to vertical, then you get J factor. Okay, kemudian tadi no sharing, now sharing. precision gears. Okay, sharing. This is the graph, numbers of teeth in mating gears. Okay, this is the numbers of gears, numbers of teeth. Pinion. Okay, this is a pinion. Pinion. Numbers of, okay, this is 20, the J factors, numbers of teeth. Okay. Pinion, this is pinion, and this is sharing. This is the gears, mating gears. Pinion, carikan dia ada beberapa numbers of graph, then match. So that, for example, the this is the 30. Okay. Pinion 30 and gear 35. Okay, sharing. So this 30, 85. So you get this value. Okay. This is 20 degrees. This is 25. Sama juga, at the bottom is no sharing. So you need to find different gears, pinion gears for this graph. This is the for no sharing. And sharing is the pinion. This is the gears. Yes. Apa the factor lagi? What's the other factor? KV. Velocity factor, KV. So KV also depending on how the gears being manufactured. Okay. So you tengoklah kan. This is pitch line velocity. Then you get KV. Okay. So it has different category. A, B, C, D, and E. And you will use different formula, different equations for different types. Okay, different types of manufactured. Okay, either hopping, shift position, shift ground, high position, highest position, shift and ground. So either A, B, C, D, and E. Okay. What is the other factor is K0, overload correction factor. Okay. Uniform, moderate shock, heavy shock. Heavy shock, moderate shock, and uniform. This is driven machinery. For motor kan, motor, driver and driven. What is type of driven machinery? And then this is source of power. And suppose sama that medium, like shock medium. So you tengoklah. And the one is mounting KM, mounting correction factor KM. KM. Based on the phase width. Okay. Then this one lah, the factor. Accurate mounting, less rigid mounting, accuracy and mounting such as less than full face contact axis. So gantung kepada keluasan the face width, for example 9 inches, and accurate mounting, small bearing clearance and precision gears. So you take 1.5. And also reliability factor, okay, correction factor, KR. 90%, 99%, okay, and depend on the reliability, then you take KR. Okay, this is the bending. Okay, this is the bending. Another one is the strength. But kalau safety factor, sebab safety, if the safety factor is equal to strength divided by the bending applied kan, bending. So we the first we calculate, we find the bending. Then also we need to calculate the strength of that gears. Okay, the strength of that gears. Then we get the safety factor. So the strength of the gear, the material used, we use this one. And macam like a static failure. So pun ada the basic is from the standard enduro limit as this one, from the materials. SN. Okay. And then add on or multiply to all the factors. Okay, ini all factors ni coming from you punya fatigue failure. Okay. CL, CG, CS, then KR, reliability factors daripada sebelum tadi. And KT, dia masuklah, tulis kat sini. Dan KMS, mean stress factor. Mean stress factor, anda kata idler 1.0, one way bending 1.4. Okay. Temperature factor, KT, for steel KT, okay. Okay, 1.0 less than 160. And then using the formula KT if KT more than 160. Using the formula. Reliability factors, tadi yang ditunjuk tadi. Gradient factors. Okay, this the diameter pitch. CG. And load factor. Kalau bending, load factor, of course, we are talking about bending kan. Now is CL is 1.0. Okay, only the surface factor. Surface factor, kita gunakan, we use same as in our fatigue failure. Okay, we use same as in our fatigue failure. Okay, this is how the load and the stress fluctuate in driving, driven, and idler gears. Okay, the safety factor for bending can be taken as a ratio. Okay, inilah safety factor dia. Okay, this is the bending on the gear tooth and the strength of the material used for the gears. So since factor Km, Kr have been taken into account, safety factor need to be not to be large. So typically the safety factor is 1.5. Okay. Okay, take a look at the examples. Gear horsepower capacity for tooth bending fatigue failure. So this is bending fatigue failure. So we have first driver from electric motor, 1,720 RPM. So diameter pitch 10, numbers of teeth for pinion is 18, and the angles is 20 degrees full depth teeth, material teeth 330 Brinell hardness. So this is pinion, this is the gears, so different materials. And then given manufacture of pinion and gear correspond to curve D. To curve D maksud dia velocity factor nanti you akan tengok on the curve D. So the equation is figure above show a specific application for pairs of spurs gear. Each width is B 1.25 inch. Then estimate the maximum horsepower that the gears can transmit continuously with only 1% chance of encountering tooth bending fatigue failure. Okay, so you kena kira sigma and Sn. Okay, so for the strength, Sn, so bending load equal to 1 CL, Cg, so since more than 5, so take 1. And CS, you tengok you CS, this is CS. Okay. From the Britnell harness. Kan? The Britnell harness, different for the pinion, 290. For the gears, terbalik. Pinion is 330. For the gears, 290. Hot roll, S-forge, corrode, insult, tak ada kaitan langsung ni. So kaitan dia ialah most is machine and cold machine. Okay, you buat gears kan guna hopping. Hopping maksud dia hopping lah, pusing. So machine. So just take for the machine, for the pinion 330 Brenner harness 330. Dapatkan 330, then this is 330. Then go down and machine get this value. For the gears 290 Brenner harness 290. Just have draw the line, straight line, then you get this value. So you get the value 0.7 for gear and 0.66 for pinion. And KR 99%. Okay. KR is 99%. 1% chance of encountering tooth bending fatigue failure. Reliabilities. Okay, reliabilities 99%, 1%, 0.814. KT and one-way bending, no idler, one-way bending, so no idler, not idler, so 1.4. Okay. So SN, this one is because the given is hardness. Okay. You have to refer the previous topic, fatigue failure. Fatigue failure. Given is B Brinell hardness. Kalau given is SUT, ultimate strength. So what is SN? So for the Brinell hardness divided by 4. So you will get SN. So once you have consider all the modifications factor CS, CG, CS, KR, KT, and KMS, everything. So multiply with SN prime, then you get the strength of the material, the gears itself. Okay? So this is the strength. For the bending fatigue stress, for the bending, this is the formula for the bending. So diameter pitch given, B is given, okay, J for pinion, J for gears. Okay, just refer to the tables, then you get the value. Then for the KV factor, velocity factor, and the question the question state that in curve D, okay, curve D. So refer to tables 1524. Okay, refer to tables 1524. So this is figure 1524. So D, this is the equation for factor. Okay, so KV, so 1200 plus V divided by 1200. So you need to calculate the V, the linear pitch line velocity. So pitch line velocity, this is the formula. Okay, masukkan formula ni, then you get the V. So just insert the value for V, then you get 1.68. Find the KO, find the KM. After that, you get two values, two equation, one for pinion and one for gears. Okay. In the FT, okay, FT. So the thing is, we need to, the equation is to maximum horsepower, HP. Maksudnya kita akan kira this value lah. Okay. So mean that we have to, maximum horsepower means we will use this formula. Okay. This formula. Then we need to get tangential force. This is tangential force. Sebab kan kita this is gears and this is tangential force. So for the safety factor equal to 1, not given, safety factor for equal to 1. So we have calculated the strength for the pinion and the strength for the gears as well. After that, we get FT. Then hence pinion is the weaker member. Why we choose pinion? Why we choose pinion? Because the pinion will fail first. Okay, the pinion will fail first instead of gears. Okay. So therefore we choose the pinion. The pinion is the weaker member. Kalau kita pilih gears, kan, the tangential force 6,002. At the end, we apply this tangential force, we will see that the pinion will fail. Okay. So we just insert the value of tangential force to the power, then we get the value. So the transmitted power for Spurs gears is 13.8 horsepower. Okay, ada soalan. This is the bending. Okay, just refer to the tables. Only two equations. One equation for strength, one equation for bending. Then all the factors just refer to all the tables. Kena tahu baca table lah. Kan? So another factor of failure beside the bending is the surface failure. Okay, this is surface fatigue, surface failure. Tadi bending, and this one is surface. Okay, due to a contact stress dekat permukaan gigi tu. Sama juga macam same as bending. Okay, bending apa kita ada? Bending kita ada this one, this factor, safety factor equal to Sn divided by, okay, this is the bending, this is strength. Okay. For surface fatigue failure, sama juga kita ada apa? The N, and then kita ada strength, kan? Kita ada strength macam ni, strength, tapi dia for the surface, strength is SH. For the fatigue surface, okay, surface fatigue stress, kita ada sigma H. This is for surface. It's for surface. And this for bending. Sama dia. Cuma equations different. Equations. So this is the equation for surface fatigue stress. This is the surface for strength, okay, of the surface. Okay. So kat sini apa ada? We have here is CP. Then we have sama juga tangential force, B surface width, and pitch here is dP, pitch diameter. Okay, you ada then you have I geometry factor, this geometry factor. This is CP. Okay. Then KV, KO, KM. Okay, then strength, surface fatigue strength. Okay, this from the table. Life factor, then CR the liability factors. Okay, for the CP already given. This is the equation for the table for elastic coefficient CP. You boleh kira jugalah. Kan? Kira. Ataupun elastic coefficient given value for elastic coefficient CP. For the Spurs gear, this is in PSI, and this is in megapascals. And also for the fatigue surface strength, surface fatigue strength, SFE, pun dah diberi juga. And Tadi Britnell harness untuk bending pun dia boleh refer table dalam fatigue failure theory. Untuk surface fatigue strength SFE pun sama juga. SFE, this is KSI, this is megapascals. Okay, for the steel megapascal 28 time Britnell harness. Okay, to 39 MPa. Okay, so the initial data you need to know the Britnell harness. For the cast iron, 20 given 55, 30 is 70, and all the data given.
Dia makin jauh ke dekat kan? Mengat 12 kan? Mengat 12 kan?
For CLI, you need to know the surface fatigue life, number of cycle. And reliabilities, refer to table 15.6. Okay. Okay, the previous equation is the bending, kan bending. Now, surface fatigue. Soalan adalah sama, tapi untuk surface fatigue. Surface fatigue. 1% charge. Estimate the maximum horsepower.
Gigi aku bodoh. Asal kelas.
Okay, first calculate the strength sebab kita tahu this is the formula. So like a bending for the surface, nanti kita akan equal to strength SH divided by stress. So the material is CSFE, the material is steel. So using this formula, then you get this value. Okay, then calculate the life for the gears, you get the value, then refer to the table, get the CLI. Reliability factor, 99% reliability, refer to the table. So you have to refer to the right table. Then multiply, you get this value. Okay, then CP, okay, from the tables, you get this value, CP, dan table dapat refer pada table, kan. Kemudian kita nak cari, nanti kita akan refer this one lah, cari this one, nak cari tangential force. So BD given, this one given I, okay, I using the formula, okay, using this formula, just what is R? R is the ratio. Okay, then you get the value, this value. Get the I. Okay, KV, KO, and then 1.6. KV already calculated. KV. This is KV. 1.68 KV. KO 1.25. 1.25, KV 1.68, K0 is 1.25, KM 1.6, KM. Okay. Then masukkan the value, all the values, safety factor, masukkan all the values, then equal, since safety factor equal to 1. Okay. So FT is 129 pound. And transmitting power is only 3.2 horsepower. Okay, so you see that for bending, 13.8.
Ku janjikan bahagia.
Bending horsepower is 13.8 horsepower. Okay, for surface, that's 3.2. And so which one we want to consider? Which one we want to consider? So we have to consider the last one. Okay, yang paling kurang sekali.
Good.
If we consider this
Alright.
with the
Good.
tangential force, this 129.
Aku dah habis lah.
This is
Macam sini dah aku dah mandi tu.
561.
Aku
It's a
punya
561.
ikutlah hantar member teruk.
561. It's for bending.